Hi, this is question 20 from NBHM 2022 paper. I hope you have gone through the question before. So what this question is asking is to find out basically the degree of field extension for these irrational numbers. So I'll go through briefly once again. So we have a topology on the set of complex number by the following prescription: a subset Z of C is closed if and only if there exists a polynomial fx with rational coefficients such that Z is precisely the set of zeros of fx. Okay, so for example, if we have iota, so what is the closure of this iota that we want to find out? So iota is a root of x square plus 1. So any polynomial in x square plus 1, any polynomial in x square plus 1 will be so I will satisfy the polynomial, any polynomial in x square plus 1, and that gives so any polynomial in p of x square plus 1. If you take any polynomial p of x square plus 1, then p of I will be 0. But the question says that but we know that closure of a set is nothing but the smallest closed set containing closure of a set A is smallest closed set containing A, right? So that means we want to find out the minimal polynomial. So that implies we want to find out the minimal polynomial, that minimal polynomial satisfied by iota by I. So that gives rise to so there is only one polynomial, which is x square plus 1. And what are the x square plus 1 equal to 0? So what are the roots of this polynomial? This is plus minus I. So we got that I closure Zi is nothing but plus minus I. So similarly, in the question they have asked to find out the closure of root 2 plus root 3 and e raised to 2 pi I by 15 and number 3 pi. So first one, we come to the first one. So it's basically a degree of field extension problem. What is the degree of field extension for root 2 plus root 3? So it's quite simple that we take x equal to root 2 plus root 3. This implies x square equal to 2 plus 3 plus 2 root 6. This implies x square minus 5 equal to root 6. That implies x square 4 minus 10x square plus 25 equal to 24, right? Let's give x equal to 4 minus 10x square plus 1 equals 0. So this is the minimal polynomial containing root 2 plus root 3 as a root. And what is the degree? So degree is 4. So the cardinality of closure of root 2 plus root 3 will be equal to 4. I think this is clear, right? So in this question basically they're asking the degree of field extension for the following numbers: root plus root 3, exponential 2 pi I by 15, and pi. So now come to the second one, exponential 2 pi I by exponential 2 pi I by 15. So this is basically zeta 15, and it satisfies x to the power 15 minus 1, this polynomial. But these kinds of polynomials are known as cyclotomic polynomial. So for cyclotomic polynomial, we have very good results combining number theory and this field extension, degree of field extension, which states that the degree of field extension for zeta n, degree of field extension for zeta n is nothing but phi of n, where phi is the Euler phi function, which counts the number of coprime with n, which counts the integer which are coprime with n. Euler's phi function. So basically we have to find out phi 15, and we know that phi is multiplicative function. From, if you have some, you might already know this result that phi is multiplicative, and you can find this result in Barton. It's a quite well known result that phi is multiplicative function. So we can split that phi 3 into phi 5. So for how many phi 3? How does you compute phi 3? That is basically 3 into 1 minus 1 upon 3 and 5 into 1 minus 1 by 5. So it gives to 2, it gives to 4, which is equal to 8. So what is the degree of field extension for e power 2 pi I by 15 is equal to 8. That's nothing but equal to the cardinality of the closure, as it was mentioned in the question paper. So for the third one, so you have to find out the degree of field extension for pi, right? So is there any polynomial satisfied by pi? Is there any rational polynomial satisfied by pi? The answer is no, because if pi was satisfied by any rational polynomial, then pi could have become the algebraic number. But pi is transcendental, but we know that pi is transcendental. So the degree of extension is infinity. Okay, so these are the for first one we have the degree of extension is 4. For second one we have degree of full extension is 8, and for the third one we have the degree of full extension is 3. So these three are the answers for these questions. I think it's pretty clear here. Yeah, thank you.